So we're going to go ahead and inspect that venting on the outside, and we need to inspect it on the inside too, correct?
Correct. So what we want to do is just inspect all the venting, right? You want to see what size venting you're using. You want to see how far your distances are. You want to see what type of elbows you're using, whether they're long sweep or short sweep, right? You want to make sure all that stuff's correct, right? It's all in the manual. It's all laid out in black and white. It has to comply to that. For example, an old power direct vent, you can only use 3-inch venting.
Okay.
On the old style ones, you can only use 3. It's all you could use. On this new one, you can use different vent sizes, right? And so you're going to have different venting requirements now, because on the other one where you only had one vent size, you could have this minimum amount of feet, this maximum amount. Now you may be outside the ranges, using this new product that has a lot more versatility built in it. So you just want to go by the manual.
Because you can go a lot further with these now, right?
Correct. These will go further.
Yeah.
So you want to go by the manual, make sure you're using the right amount of vent, you have the right amount of distance you're supposed to have between elbows, that you're using the proper elbows, because on the old ones, a 90-degree elbow, it didn't specify whether it was long sweep or short sweep.
Right.
It just said a 90-degree was 5 feet. On this one, we know a short sweep's 8 feet, a long sweep's 5 feet.
Okay.
Right? And, so there's more stuff that goes into it, and you also have to remember that these vents, they need to kind of follow each other as close as they can.
So do we want them mirrored? Do we want...
As close as you can get them. You want them to mirror each other as close as you can.
Okay.
Right? And there's specific requirements for that in the manual. So you want to make sure it complies to all that. And what you're going to find out on doing this is 9 times out of 10, that's where it's messed up. You're going to go through, the venting's going to be installed incorrectly.
Okay.
They're using the wrong termination screens, or they have too many elbows, or they're going too far, or it's just, it doesn't meet the requirements. So you want to make sure it meets the requirements. Now, if it does meet the requirements, next thing you want to check would be, is the venting clear?
Yeah, but like you said, this is where they're going to find it, right? This is
Most of the time.
Usually based on our data that we get, because we've got our call centers, we know what's going on in the field. Usually it has to do with either the termination or it's the wrong vent.
Yeah, they're using an existing vent system that doesn't meet the requirements for this. So yeah, check the terminations, check the vent system. You'll probably find the issue.
Okay.
But say we move on even further, right? All that's fine. We want to verify that it's clear.
Okay.
Right? Stuff happens in venting. Critters can get inside of it. Right. So especially if it was missing the screens or something, right? So you want to make sure all the venting requirements are met, and that's clear. There's 2 ways to see if it's clear, right? If it's a long vent run, you can't see through all of it, then you'll either need a bore scope. We can run a little camera through it. It's a fancy way of doing it. I can look on my smartphone, see if anything's moved into the vent system. Otherwise, what I'm going to have to do is I'm probably going to have to cut it, right, and inspect certain sections of it to ensure that's clear, which most times not a big deal, because the couplings to connect it back together, PVC glue is relatively inexpensive, right, and it dries quick and do it pretty quickly, right? So we want to ensure that the correct terminations are used, the terminations are spaced properly apart. You want to make sure that the venting distances are correct, using the proper amount of elbows. You haven't exceeded the vent length or anything like that. And then you want to make sure the venting's clear. Okay. Right? We know, like we said, most of the time you're going to figure out with the 3 flash code, most of the time it's venting. But let's say all that stuff was correct.
Yeah, and I mean, that right there is, I mean, really, you don't have to really any tools other than like a tape measure, bore scope. I mean, you're not using anything like a multimeter or anything like that. You're using your eyes and your hands.
Yeah, I mean, and typically you could do, really you could do most of it with a tape measure. Yeah. And maybe a saw and some cufflings and stuff, right, to glue it back together. So, I mean, it doesn't have to be anything too fancy. Okay. But I like to start simple, right? Sometimes you never want to overthink something. Okay. Right? A lot of people in power vents automatically go to pressure switches and blowers. Exactly. When that stuff's, pretty high quality control and it rarely ever fails. Yeah.
But you get to a certain situation, I mean, you will have to do that from time to time. Let's say we went ahead and we checked all the venting. Venting's clear. It's the right venting. We got the right terminations. Then we will have to start testing those switches.
Correct. Which means we're going to need some specialty tools. Right. I mean, that's going to be the time we have to break out usually a digital multimeter and then a digital manometer. Okay. Now, this heater is a little bit different because of a standard power vent. Standard power vents usually have a normally closed vent temperature limit switch, and then a normally open pressure switch that closes when the blower kicks on, right? This water heater, since we have two pipes, we're monitoring those pipes separately,
Okay.
right? So you have a blocked intake switch and then a blocked exhaust switch. And then you still have your vent temperature limit switch. Since we're using plastic venting, we want to protect that. In case it ever gets too hot, it shuts the water heater down as a safety. So the intake switch is a normally closed switch that opens if the intake's blocked.
Okay.
Right? If the intake's blocked, it's going to create back pressure and actually blow the switch so its contact's open.
Yeah, normally closed means it's going to stay closed, and that's its normal state. When the heater's off, it's normally closed. It should never open up, right?
It should never open up, and if
Okay.
it does, typically means your intake's blocked. Your exhaust switch is the one that's normally open and then must close. It must close every single time for the water heater to kick on,
Okay.
right? Because it's just monitoring the draft, going through that. And that's what we're doing with this heater. With the two pressure switches, we want to make sure our draft is within a certain range,
Okay.
right, between the pipes. And so that's what it is. They're both negative pressure switches. It's just activation points are different to make sure that we're within a certain range of the vent.
Okay, and then we have our high vent temperature switch.
Correct.
Which is all daisy chained together. They're all on the same circuit. And this area code 3 is saying that that circuit is open.
And that circuit is open, but we don't know which switch is
All
necessarily
right,
open.
so what do we do first?
Well, in this heater, a couple things you want to do first, and you want to start simple once again. For us to create draft, the blower motor has to kick on, right? And so with this code, typically by the time you arrive to it, it's going to go to a 3-flash code. Blower's not running, nothing's happening. So we know the blower must run. So what we want to do is turn the power switch off,
Okay.
turn it back on, and then see if the blower motor starts.
All right, so we turn it off, turn it back on, and if the blower motor doesn't start, that's something else, isn't it?
Yeah, if the blower motor doesn't start, that's typically going to be an issue with the blower capacitor.
Okay.
These water heaters, like a lot of our newer power vent water heaters, actually use a small blower capacitor, right? And what that does is just provides twist to start the motor.
Right.
Right, and so if it's a 3 microfarad capacitor,
Okay.
so if the blower's not starting, usually the easiest thing to check first is just change that capacitor, see if the blower motor starts.
Yeah, so carry it on your truck, go ahead and take a capacitor, 3 microfarad, take the leads off of the capacitor that's on the blower, put them on the new capacitor. If it starts, just replace that. If not, then we've got an issue with the blower, right? If it doesn't start.
Yeah, usually if we change the capacitor and the blower motor doesn't start, that's typically going to be an issue with the electric motor part in the blower, which would mean the blower assembly needs.
But that's not a common issue. That's usually it's the capacitor in that case, right?
Correct. Usually it's the capacitor, which it's a good thing. It's separately replaceable.
Right. All right, so let's say, the blower does start and we're still getting that code.
If the blower does start, then the next thing we really need to check is to see, and this is quite simple, I want to make sure both my sensing tubes are hooked up.
Okay?
So what I have to do is I have to remove the cover that blocks all the air pressure switches. Now I can see one sensing tube with it hooked up. And so this sensing tube you can see with it hooked up is typically just a little tube, right? That's actually hooked to my intake switch,
Okay.
right? And so I want to make sure it's connected to the nipple, on the pressure switch itself, and then the barbed fitting on the blower housing,
Okay.
right? But I also have the exhaust switch, and I cannot see it with the cover on, right? I can't see either one of these switches. So I have another little elbow that's just an elbow, right? And so I want to make sure it's connected to the pressure switch on the one side and then the barbed fitting on the other side,
Okay.
right? If all that's good, then what I typically want to do is get some blower pressure readings to see what's going on in my blower housing, to see,
Okay. See which switch is opening.
yeah, to see which switch is opening.
Okay.
Now, since I have the cover off and everything, usually the easiest switch to verify first using a multimeter is to do a continuity check on the vent temperature limit switch
Okay.
to make sure it's in its proper position. So what I want to do is get my multimeter, set it to continuity, right? And continuity on this multimeter is going to give me an audible tone if I have continuity. So if I touch the leads together to test them, right, it
Okay.
beeps showing I have continuity. Right, and so what I want to do is have the cover off. I'm going to remove the 2 wires that go to the vent temperature limit switch. And I want to get my multimeter leads and just hold them on the 2 terminals and see if my meter beeps,
Okay.
right? If it doesn't beep, right, then I know my vent temperature limit switch is open. And if I if the blower's cool to the touch and that switch is open,
Right.
that switch is typically bad.
Then we replace the switch.
Yeah, you just have to replace just the vent temperature limit switch.
Okay.
Most of the time you're going to check it, vent temperature limit switch is probably going to be closed.
Okay.
Right, but we always want to verify that's in its proper position. Next thing I want to check is I'm actually going to want to remove the pressure switches.
Okay.
Right? They have little stickers on that tell you the force needed to change the switch's position. And then I'm going to use my digital manometer, and actually check the pressure of the switch.
Okay.
And so there's two switches that read two different sides of the blower motor, right? And so I can check my intake switch, compare that to the intake pressure I'm getting.
Okay.
And then I'm going to check my exhaust switch and connect that with the, compare that to the exhaust setting.
Okay.
Right, and see, the blower motor should be pulling more than enough vacuum inside that range to close that exhaust switch.
Right.
But usually what happens over years, since that exhaust switch works time and time again, usually the intake switch never usually works. I mean, it's always closed, never changes position. It's all about the position change, right? I'm just getting something, bending it back and forth.
Right,
It's
right.
eventually going to break. What you may see is that the exhaust switches fell.
Okay.
So I want to check my blower pressure, right, and compare that to the activation point of the switch. If my blower's pulling more than enough vacuum to close the exhaust switch, right, then that means, and the exhaust switch isn't closing, that means the exhaust switch is bad.
It's bad. Right. Okay.
Right? Same thing on my my other side, on my intake side. If my blower motor's creating, enough pressure to push that switch open,
Yeah.
that means you didn't check your intake pipe typically good enough, and you want to go back and verify that intake's
That has
clear.
to do with venting. Yeah.
Correct, yeah. Since it's a normally closed switch, it should never change position, right? And so that's why it's so imperative, to check it. Now, if I check the switch and it's open, right, and the blower,
It's underneath the activation point.
yeah, and it's underneath the activation point, then the intake switch is bad.
Okay.
It's just very rare that a switch that's normally closed and really under normal circumstance should never change position fails.
Right.
Right, and so most of the time you're going to find the issue with your exhaust switch.
Okay.
If one of them's going to fail.
Yeah, because it works. It does the most work.
Correct, it does the most work since it changes position
Okay.
every time.
All right.
But that's typically it. So if you check your exhaust switch, right, and my blower's creating enough vacuum to close the switch and the switch isn't closing,
Then we got a problem with the switch.
you got a problem with the switch. If I'm not creating enough vacuum, then I have a problem with the blower. As
Okay.
long as all the other stuff we previously checked was right. The venting was clear, proper terminations used, elbows are proper distance apart, and all the specs that are lay this out very specifically in the manual.
Okay.
So you always want to make sure that stuff complies to the manual, because if you don't, then none of this other testing means anything.
Yeah, so the big thing about this is, on this code, you really need to think about the terminations, putting the right terminations on there, and then, on the venting, make sure the venting is clear, it's the right size. We're trying to mirror the intake and exhaust together, going out the same wall, if you're going out the roof, you're going out the same.
Yeah.
And if you're using a concentric vent, you've got it hooked up right.
Correct.
On the exhaust is going in the right part, and the intake's on the right side.
Correct.
Because, if you get those reversed, you can create too much pressure as well.
Yeah, usually with most of your modern concentric vent kits, you have a piece of pipe that's going straight where you connect, and you have one that's elbowed in. The elbowed in one, the usually one at the angle, is your intake pipe,
Always.
and the exhaust is the straight one, right? But then there's also different concentric vent kits from other manufacturers. You always have to use the one we specify in the manual.
Right.
And so if this water here is replacing a different brand, and that concentric kit's not the same, the heater's not designed or tested with that.
We can't tell you what it's going to do because
we
it's not
can't tell.
designed and not tested that way. You're exactly right. So that's Error Code 3. Remember, you got to keep up with keep your owner's manual, bounce everything, all your questions off the owner's manuals in regards to how far the venting, in the correct terminations is very, very important.
Yeah.
All